All right. Hello, everybody. Good afternoon. Thank you for joining us for today's WiCyS webinar with Google presenting on securing open source hidden in plain sight. My name is Morgan Garland. I'm WiCyS Operations Manager. And with us today is Azra, Sarah, and Kara, who are going to be presenting our webinar. Before we get started, I just wanted to go ahead and give you a brief introduction of the WiCyS organization and who we are. We often go by our acronym WiCyS, as in We Sisters, because that's exactly what we are. We are a global cyber sisterhood. We are a 501c3 with over 5,800 members in 70 countries. We are the premier organization with a global reach dedicated to bringing together women in cyber. Our mission is to recruit, retain, and advance women in cybersecurity. We have a bunch of great WiCyS initiatives, all made possible by our supporting strategic partners, such as Google. We have our professional affiliates, student chapters, our volunteer committees, mentor-mentee program, Job Board Plus Plus, member forum, and so much more. You can view all of our training programs and initiatives on our website at WiCyS.org to learn more ways to get involved with the WiCyS community. And all of our wonderful initiatives are made possible by our strategic partners. Our Tier 1 partners being AWS, Battelle, Bloomberg, Carnegie Mellon University Software Engineering Institute, Cisco, Fortinet, Google, who's bringing us our cybersecurity awareness webinar today, Intel, Lockheed Martin, Meta, Microsoft, Optum, Sandia National Labs, and Sentinel-1. And just a reminder to ask questions. There's going to be a chat box. You can drop your questions in there, and the presenters will get to the questions at the end. And ask away. We have the experts here with us today, and they look forward to hearing from you in the audience, so please do not be shy. And if you haven't done so already, please be sure to subscribe to the WiCyS newsletter. You can do so on our website at WiCyS.org and stay up to date on all of our great events, upcoming initiatives, and more Cybersecurity Awareness Month activities. With that, I'm going to turn it over to the Google team to introduce themselves and get started with today's presentation.
Great. Hi. Thank you. I'll just get the slides up. I'm Kara Olive. With Azra, we're going to talk today about our work to secure open source software. So here's our agenda for the day. We'll cover briefly what is open source software to get everyone on the same page. We'll talk about some of the security risks that are specific to this area. We'll talk about some of the security solutions that we're working on. And then we're going to spend some time on how you can get involved if you're interested and some career opportunities. And of course, there's lots of time for questions at the end, so please do ask. Okay, so what is open source? As you probably know, open source software is code that is freely available to the public. Anyone can use it, anyone can inspect it, modify it, which is great because it speeds up the rate of software development, allowing more creativity than if everyone had to build everything from scratch. You've almost certainly used open source software yourself because at this point, open source code is almost everywhere. In fact, the average app is now 90% open source components. This number is based on a recent study by Sonatype. A great analogy I've heard is if you imagine a piece of proprietary software as an iceberg, the visible tip of that iceberg above the water is the new specialized code. And then everything that's hidden underneath the surface of the water, all of that iceberg underneath would be the open source projects that are acting as its foundation. And it's not industry specific either. This slide shows an image from a study by Synopsys. They surveyed software code bases in different industries to see how many of those code bases used open source code. And as it turns out, it was almost all of them. 96% of enterprise software, 93% of healthcare, 97% of financial, and 100% of the surveyed energy industry code bases contained open source code. So just about everything is using open source, and all of this code is open to inspect. So what's the problem? Why is this talk titled Hidden in Plain Sight? Excuse me. Here's a big reason why. A study by Veracode had found that 70% of applications surveyed had an open source vulnerability. But the real takeaway was that almost half of those vulnerabilities, 47% of them, were transitive, meaning that the vulnerability was hidden in indirect dependencies, not in the project you might be using directly, but in a project that that project was using, or even further down the dependency chain. It could be like 10 levels even. So if you're in the situation on the right side of this slide using a package that itself has a vulnerable dependency, you might not be aware that you're affected. So that open source iceberg below the surface of the water amounts to a lot of hidden code, even though it's all technically open. And on that note, Azra is going to take over, and she's going to tell you more about the risks and attacks specific to this area.
Yep. So hey, everyone. I'm Asra, and so I'm going to start my part of this talk talking a little bit about the overview of why open source has unique challenges in security that may not happen in other types of environments like closed source software or enterprise software. So I'll dig a little bit into the sort of fundamental reasons, and then I'll also talk a little bit about some really awesome but not so awesome attacks that have happened in the recent years. So let me just get right into it. So there are two problems that lend itself to these, particular challenges. And the first is, well, it's open source, and the second is it's software. So obviously, it's a little bit silly for me to frame it that way. That's exactly what open source software is. But both those pieces, it being open source and it being software, lend itself to really unique challenges. So the first, it's open source. So open source by nature is going to mean that it is free to use, so free for you to consume, free to contribute, and also free to inspect. So you're allowed to go and look at the actual lines of code. And sometimes you're able to actually look at the review process and the people who are contributing that code. So when you're using an open source software package, you should be able to see everything from at least the lines of code all the way to where it's being distributed. And then, like I mentioned before, you can sometimes see even more details, including review processes, build processes, maintenance processes, and so on. So some of you already are probably familiar with this type of process because maybe you've contributed to an open source project, or maybe you've created your own open source project on GitHub for maybe a class project or for work. So the flip side of, the actual benefit of, being able to consume and contribute to a free project is that the people contributing and maintaining the project have constraints. Sometimes, these projects are built off of community efforts, and they require community members to step up and test and review and build and maintain and do everything that is required for like a nice and secure build pipeline to work. And unlike enterprise software, there's this reliance on those community members to do that. Whereas maybe if you're, working at a company and you're maintaining your entire software stack yourself, you're actually paid to maintain and test and so on, rather than in the open source when there's people who are doing this just because of their own interest or free will, which is awesome. But again, people have constraints. So there's also less access control over who can actually alter that code, who can distribute that software, and where that software is coming from. So that's a whole attack surface that isn't the typical in enterprise software where you know who your employees are. So the second is probably one that is more familiar across enterprise and open source, is that it is software. And so like I mentioned, like software is written by humans. There are lines of code that we're writing and testing and building ourselves, and all software has bugs that can be exploited. No matter whenever you think it's done, it's a problem, like a whack-a-mole problem, and it's just always going to have bugs no matter what. The space is evolving, usage is evolving. It's a never-ending problem. So those of you who are like maybe familiar with cybersecurity and bugs know that there are all sorts of different types of bugs. There's all sorts of interesting ways that bugs can be exploited. Sometimes a feature can actually be used as a bug. There is one type of difference, I guess, in the types of bugs that proprietary software and open source software see when it comes to security exploits and vulnerabilities. With proprietary software, most of the time you've all heard of 0 days maybe. So 0-day vulnerabilities are unknown to the people distributing the software and often unknown to users, and they're not reported. They're something that attackers are using to exploit a certain type of application. And those are the typical big threats when it comes to enterprise software. So hackers are usually trying to find these 0 days or search for them through other channels, and then use those 0 days to find exploits. On the other hand, in open source software, the space is a little bit different. So open source software is usually used as that dependent code that, Kara showed that tree of before, where there's a single, commonly used open source package that ends up in lots of different applications. So with open source bugs, usually it's a known vulnerability in a very, low stack, deep in the stack package, and attackers or hackers will exploit those known vulnerabilities to the target application they're trying to find. So instead of treating the code like a black box and trying to find these unknown vulnerabilities, a lot of the time they're taking these known vulnerabilities as a free lunch and relying on the fact that a lot of top of the stack applications still have that exploit inside them somewhere deep in the stack. So obviously some very common open source packages end up in thousands and thousands of applications, and targeting a single known vulnerability there can mean you basically can get a free lunch. So the other part about open source bugs, alluding to this sort of problem of known vulnerabilities, is that it's not so easy when you're an open source maintainer to triage and fix bugs in open source code that you're using. So sometimes you can have a really complex dependency tree like Kara brought before, and it will require you to update your dependency and then update your dependency's dependency and update, so on and so on. And that process takes time, and that time is time that you're vulnerable. So let's quickly wrap up some of these ideas that I brought up. So open source risks are pretty unique, and it's kind of an interesting space because the benefits that we are actually getting from open source are actually the points that are causing the vulnerabilities as well. So yes, it's free, which makes it awesome to use. It makes it great to contribute to, but sometimes it being free doesn't necessarily mean that it's quality code. And yes, anyone can contribute, meaning you in an enterprise that is using the library, or maybe you as an enthusiast. But that doesn't necessarily mean that everyone is going to promote secure coding practices or everyone is going to fix issues. And then, like I said, a bug for you might be a feature for someone else. And then also, yes, it's easy. It's easy to add code. It's free. It's easy to add features. But sometimes it being so easy can sometimes mean that without that governance that you get from enterprise software environments, it's easy to contribute bad stuff as well. And then finally, it's transparent. So it's easy to find bugs because you can see those actual source code lines, but only if you're actually trying to find it. It can also be opaque when you think of the code contribution and build process. You don't necessarily know the identities or the people that are contributing the code. Do you trust them? Are they malicious? Who's building it? Who's distributing it? So open source software doesn't necessarily mean a well-regulated and secure life cycle. And just to kind of show you an example, open source software is a giant ecosystem. And many of you probably recognize probably like half of these icons at least. There's Kubernetes up here, Firefox, Python, Linux. And many of you have probably used some of these platforms like GitHub to contribute to open source projects. And so it's like a benefit, it's great to have, and it's also a risky place to be. So summing it up, when you're thinking of your own code, either if you're working at a company or if you're working in open source, a lot of it can come down to what's in your software. You might not even know what it is, which is a problem in itself. But even if you know what's in it, you may not have the most control over its maintenance and process. So one of the things that we do at Google in terms of risk management is evaluate and analyze all the spots in that software supply chain, all the way from actual buggy code, so like code that developers are writing, all the way through the build process and the dependencies, all the way to the package repository where you're pulling the code from. So package repositories are things like pip or Maven, other sort of centralized places of getting software code from, all the way to the end consumer who's pulling those packages. So maybe this is a company or a user who's using that open source package. So all of these different points have different types of attack vectors. And I'm going to very quickly touch the surface of some of these with some like pertinent examples in the news that you might have heard of. So the first one touches on the bugs and code exploits that I mentioned before. So the Apache Log4j vulnerability was a code vulnerability, so meaning a problem in the actual source code inside a really commonly used Java-based logging library. This was reported back in December of 2021, and it was a bug that would allow attackers to run arbitrary code. So in other words, perform a remote code execution, or an RCE, if you've heard that word before, by exploiting something that was like initially added as a feature in the library. So this is one of those open source problems where someone was like, this is a cool feature. And then it turns out that that feature ended up turning into a vulnerability or a bug. This one was really interesting because it was so commonly used that about 2 to 3 billion devices were affected by this vulnerability. And a large percentage of enterprises were using this as well. So some stats were that like they found that 1.2 million hacking attempts were performed using this logging library vulnerability, and over 44% of corporate networks globally were affected. So we at Google also had an incident response due to this, and it requires a lot of work because, as you can see, 98% of packages are affected by advisories, sometimes indirectly. So these can be really complex dependency trees, and it can be really hard to evaluate if you're affected or not. So all in all, a single code vulnerability in a really common used open source library leads to this huge multiplied effect. The second type of attack that we're going to talk about is, in contrast to code vulnerabilities, is actually more of like a process or pipeline vulnerability. So this type of attack is usually called a supply chain attack or a software supply chain attack. This is a SolarWinds Sunspot vulnerability that hit one of SolarWinds' products called Orion. Orion's a type of monitor or management platform that a lot of really important companies are using. So this was reported back in December of 2020, and people say it's like one of the most complex and sophisticated cyber attacks in all of history. So this was a situation where some unauthorized code, some malicious code, got inserted into their build process. And it resulted in adding a backdoor that those attackers would be able to access later on. So once customers were using their platform, the attackers would be able to access those customer environments without being detected. So this insertion of malicious code wasn't really a code vulnerability, but more of a process vulnerability, as in SolarWinds might not necessarily have had the best oversight over what was going into their code. Making their pipeline for distributing that code vulnerable to such an attack. So open source is particularly vulnerable to these types of attacks when you think of how many open source packages are included in someone's supply chain. So because everyone is depending on open source packages, pulling in malicious ones is definitely a source of vulnerability. So these types of attacks, supply chain attacks, are just on the rise. In the past 2 years or so, we've seen more and more and more of them, and there's all sorts of ways they can happen. You can inject malicious code like the one we just saw before, but you can also do things like just incorrectly pull the dependency. So you might pull a package that you didn't intend on. So as time goes on, it seems to be like an easier and easier target for attackers to exploit. So before I hand this back off to Kara to talk about the more positive side of this, I just want to quickly kind of overview what I just talked about. It kind of boils down to open source packages having code vulnerabilities because of the open nature of contributing code, and also just by nature of it being software. The second is that there's a huge process in the open source pipeline. And that a compromise in the source control system or the build process can introduce something that wasn't intended on being there. And the final part is more of a people problem. So responding to vulnerabilities, triaging them. Maybe this is something that you all have seen before in terms of like analysis or detection or response. That also requires work. And having a distributed place where you're contributing code may not have the most responsibility on on the part of the maintainers. So I will hand it back to Kara to talk about the positive.
Okay, great. So what are we doing about all of this? As Ezra said, part of what Google does is analyze the supply chain to try to protect and harden the weakest points. And since we work on the Google open source security team, we get to build external versions of the tools and processes that Google uses internally, so anyone can use them. And broadly, our approach to securing open source follows this just general framework of know, prevent, fix. So where are the vulnerabilities? Which critical projects do we need to protect first and foremost? How can we harden the supply chain to prevent new vulnerabilities from even entering the ecosystem? And what's the most efficient way to fix what we find? Okay. We work on too many projects to talk about all of them today, unfortunately. We'll cover a few, and there's a PDF linked in the attachments. I think it's on the right side of your screen if you see what I see, that has links to more projects that we work on if you're interested. Most of these projects are under the Open Source Security Foundation, the OpenSSF. That's part of the Linux Foundation, and it's a cross-industry collaboration to improve open source security. And their mascot is this goose. So we've got this goose here with the score on top of its head, the 10. That's because this first tool, Scorecards, is a tool that assesses open source projects based on whether they're using security best practices. So are they requiring code review before merges? Are they using code scanning tools? Do they have known unpatched vulnerabilities, which, as Azra said, is such a huge target in open source? How many maintainers are there? Log4j, for example, had only one maintainer, which is something Scorecards would flag as a risk factor to consider. Scorecards is not saying that a project is inherently insecure based on that. It's just giving consumers a way of knowing at a glance what the situation is, and then they can judge how they feel about that risk. Are they okay consuming something that has one maintainer or not? There's currently 19 security practices that Scorecards checks, and each of them comes with remediation tips. So Scorecards is great to run on your own project if you already have one, because you get a roadmap to help you improve your security. And it also is a really good first project to check out if you're new to this area, because it'll introduce you to lots of other tools and best practices. And since it's open source, you can contribute to add new checks if you would like. All right. Another great project, SigStore. Ezra's very involved in this. I'm sure she'd love to take questions about it if you have any at the end. SigStore is in the protect category. It's a suite of tools for free cryptographic signing that requires no key management. So with SigStore, you can sign your software releases or other artifacts, and someone who downloads whatever you sign knows that they've gotten the right package. So in the case of SolarWinds, as Ezra mentioned, the compromised builder swapped out source code, but if there had been a signature on that code, it would have been possible to verify and know what the end product was, know that the end product was tampered with. And in fact, SolarWinds has since adopted SigStore. One last defensive effort. This is the Linux kernel self-protection project. It works on hardening the Linux kernel, which is the heart of so much of all internet infrastructure today. 2.8 billion Android phones, our cars, the International Space Station, Mars rover, these all run on Linux. This project works not just on fixing bugs, but on preventing entire classes of bugs. So for example, there was an announcement just in the past couple of weeks that Rust had been incorporated into the kernel, which is huge because it's a memory safe language, unlike C. So using Rust closes off the possibility of developers accidentally introducing new memory safety issues. And then on the offensive side, go find bugs, fuzz everything. We do a lot of fuzz testing or fuzzing. That's automated testing that feeds unexpected inputs into code to intentionally cause the crashes that would indicate there are bugs there. I think fuzzing might still have a reputation of being just for memory overflow issues in C languages, but there's been a lot of recent developments in this area. Fuzzing can now detect other types of vulnerabilities, including command execution, arbitrary file access, deserialization. It happened after the fact, but fuzzing can now find bugs like log4j. This slide has a couple projects you can check out. OSS Fuzz is a service Google runs for the open source community. So it fuzz tests 800 critical projects in 6 coding languages, and then if it finds something, it privately alerts the maintainer. to the vulnerability. So it's gotten 39,000 bugs fixed, and 8,000 of those were security specific. The number of projects OSS Fuzz is fuzzing is always increasing, and anyone can integrate an important project into OSS Fuzz for free. In fact, they'll pay you. So if you look up the OSS Fuzz integration rewards, you'll see the rules. I think it awards up to $20,000 based on the criticality of the project you add. So that's a great way to get involved if there's a project you think they should be fuzzing. And if you want to fuzz on your own, Cluster Fuzz Lite is a lightweight option. And then one last project to mention for after you found all these bugs using fuzzing, there's OSV, or open source vulnerabilities. Think of it as CVE for open source. It's a new vulnerability format and database that helps simplify and automate the vulnerability reporting and triaging process across ecosystems. As Azra mentioned, it can be kind of hard to track this across such a sprawling ecosystem. And then our last solution, I know it's cliche, but the main solution is people. So people paying attention to open source code, people promoting safer open source security practices, people getting involved. You can add security tooling to critical projects, or you can contribute directly to developing these tools that we just talked about because they're all open source. And culture is key. You can use these tools as a conversation starter within your organization or your company, your school, your group of developer friends, and just talk about some of these open source security issues and discuss where you might be able to make simple changes that can have a really big impact. And let me hand this back to Ezra now one last time to talk about that.
All right, cool. So I am going to quickly touch on where you can get started and where you can get involved with open source and open source security before we go on to some questions. So there's a couple of internships that are focused particularly on open source, like GSOC, the Google Summer of Code, or Outreachy, which is particularly focused on diversity in open source. And that'll help, especially if you're trying to get practice or involvement in open source communities just to understand how it works. And it's really helpful to kind of get a sense of how open source as a community and ecosystem operates before getting into the security side of it. Highly recommend those. On the learning side, there's a couple of training links. The OpenSSF, the Open Software Security Foundation that Kara had mentioned a bunch of projects from, runs some trainings on software security that can help kind of introduce you on the types of tools that people are using currently to secure open source. And then finally, the easiest thing to get started, the fastest path to being involved, is really just make a GitHub account and start contributing to your favorite projects. So there's always places and projects that require security support, whether it's with bug fixing or triaging or detecting bugs. And by nature of it being open source and a community-driven project, getting involved is a really thankful effort. Like everyone will thank you for it. So again, pick your favorite project and go is kind of the easiest way. And then if you need more support, these trainings and internships can help guide for specific types of projects. Another thing that I wanted to touch on and mention over here is that there are a wide variety of roles that are involved in securing open source. And not only that, but there's a shortage of people who are qualified and have talent in open source. And we know that from our own experience as well. It takes a lot of time and patience and expertise to be working with open source. It's definitely a skill that we've been learning. And over half of employers are planning on increasing their open source hiring within the next 6 months, according to one of the Linux Foundation's open source job reports. So it's just a field that's going to be growing and increasing in size. So by nature of it being open source, it's free, it's a community-driven process. And because of that, and especially with security, it's really a holistic approach. Not only do you need people who are on the ground finding and hunting for bugs, you need people who are fixing the bugs and building the tools. You need people who are, improving the process, educating developers. So things like DevOps and DevRel. And you need people who are there to support communities, which are often found in things called OSPOs or open source program offices. And these are all cross-domain as well. Like working as a developer in open source security may mean that you are working with or collaborating with pen testers, or you're working with DevRels. I do that in my current job as well. So take note of some of these names if they interest you and the types of stuff that they do. Definitely try to look up whether companies and open source software roles are hiring in here. So at Google, I just wanted to quickly mention what types of roles that we have and careers and opportunities that we have here. And it's going to look somewhat similar for other companies as well. So Google started their first open source program office in all of industry. So the first OSPO was ever at Google, and that was created in 2004. And since then, other large companies have recognized the importance of contributing back to open source and have their own OSPOs as well. So we also have specific teams at Google. So the team that Kara and I are on, Google Open Source Security Team, the Ghost team. We also have a bunch of engineers and PMs and tech writers supporting and creating open source software security tools and progress there. So what we also have is we have some partner efforts with other companies, and we've created the Cloud Native Computing Foundation, so the CNCF, to host a bunch of open source projects that are used across companies as a cross collaboration effort. So these host projects like Kubernetes, Envoy, and other types of cloud native open source projects. And then, like Google has a bunch of products that are open source by nature. So Android, Chromium, and Go are all products that have come out of Google and released as open source. So a bunch of engineers working at Google also work their day jobs working on these really awesome open source projects. And then likewise, a lot of what we do at Google is, help support the rest of the world with the tools that we use. So a lot of our engineers are contributing and using OSS Fuzz and other sorts of projects that have come out of Google. And then finally, here are a bunch of links to blogs and newsletters that you can use to kind of keep track of what's going on in the open source security world, what types of events and hacks and things like that have been going on. Kara and I put together a attachment that should be linked on the webinar for some of these reference links if you want to discover and click on them. So with that, I think I'm going to end here. I'm super excited to start answering some of your questions, and thank you all so much for your attention.
Okay. Hi, everyone. This is Sarah Morales, a member of the WiCyS board and Googler. Thank you, Azra and Kara, so much for walking us through this. To kick us off, we didn't get to quite in the beginning of you all sharing your career journeys of how you ended up working in open source and at Google. So if each of you can maybe start with just how you got involved in your role today, and specifically then in open source security.
Do you want to start, Azra? Go for it.
Yeah. Go for it, Kara.
Oh, okay. I'll start.
They think alike.
So I'm a career changer. I only entered tech about 2 years ago, so I always want to throw that out there to women who are considering career changes. Before this, I was in academia, and I have a humanities background. I was teaching music history, but I really enjoyed explaining complex ideas to people. So I had transitioned into a technical writing career, and Ghost was my first team. I decided to go into open source because it seemed really interesting to me, and an area that there was going to be a lot of new problems and new solutions, and that I just wanted to be involved with it. So yeah, that's how I got here. What about you, Ezra?
So I also maybe kind of took a little bit of a path, but definitely still always on the technical side. So I studied math in college and was interested in privacy and cryptography. And then when I started working at Google, I was mostly doing privacy stuff. And then I started to realize it's really awesome to work on open source because you get to talk about what you do. And I liked the openness involved. And I thought that was a lot more impactful to me than working on a closed source type of feature. So I started to transition to Envoy, which is one of the CNCF projects. And I was just working as an engineer there. And then I realized that as I was doing security work over there, that the security work was really important and that I wanted to sort of scale that impact So I started looking into other teams that were doing open source security and then landed on Ghost. So I kind of took a little bit more steps, and I was kind of always on that technical side as a developer. So I'm a software engineer and have been doing that since I started working.
Wonderful. And Azra, could you share just a little bit about the Ghost team? What types of roles are there within the Ghost team, and actually within the field when you interact with folks in the public? What kind of backgrounds do folks have, and what are the different role types that you've seen?
Yeah, so like I said, I'm a software engineer. A lot of us, maybe like half of us on Ghost are software engineers, and then the other half are maybe split across security engineers. Kara's a tech writer who does a lot of work that just doesn't, it's not always tech writing. It's sometimes project management and collaboration across teams, which is super important to disseminate ideas. So we have project managers, technical program managers, and pretty much the like of that. Even just managers, people managers are also really important glue to help processes like this to continue.
And then one more kind of ecosystem question, maybe for Kara. Kara, as you're working, so it sounds like big tech companies like Google are involved. I'm sure other tech companies have OSPO offices. Who else do you see in this open source security ecosystem? Like what other types of companies might folks look toward for roles, or types of organizations exist in kind of the community of open source security?
Wow. Oh, actually, it's really, I think it's growing a lot. There's a pretty, if you wanted to go in this direction, there's a pretty good number of places you could look. I think I would suggest looking up the Open Source Security Foundation first, and then just looking at the companies that are involved there. I think starting with any of those organizations, it's showing that they're concerned in this area. I think the public sector is also becoming more of a supporter of this area. Ezra, is there anything you want to add there?
Yeah, I think you mentioned, the public sector, looking at the people who are involved in the CNCF or the OpenSSF is a good start. And then looking at people also who, like the WiCyS supporters as well. Many of them are going to have OSPOs and people supporting open source, because I think most companies now realize that that iceberg is really big at the bottom.
Yeah. So I think anyone out there interested, there's private sector jobs, there's public sector. So that's working for the government or governmental agencies. And then there's also a number of startups in the field. So you'll see participating there, but there's lots of new smaller companies that are also kind of nichely focused in this space as well, because of the size and the kind of scale of how open source is being used, throughout the internet and throughout the stacks. To dive in now, we have a bunch of questions around some of what was presented. So first, to Azra, how do you find open source software vulnerabilities?
Cool. Okay, so I think Kara did touch a little bit on this. So if you're looking at the question of finding unknown vulnerabilities, a lot of what people use is like fuzzing techniques, which is sort of like a black box dynamic test. Just throw something at a process and see if it breaks. And that can point you to a vulnerability in the code. And then if you're looking at how do I find known vulnerabilities, that too is a tricky problem. And Kara mentioned the OSV or CVE. Those are databases that people are using to report known vulnerabilities. So that can be a tool for you if you're interested or curious if there's a vulnerability in a package that you're using. You can use one of those databases to go and find that. And then the last thing that I'll mention as well is techniques like static analysis. And that's kind of similar to fuzzing, where you're trying to find those vulnerabilities. And that's a little bit more structured and processed than fuzzing. So that's just a keyword for you to go look up. Yeah.
Wonderful. And to build on that, there's two questions I'm going to combine here. So we find all these bugs. What do we do to resolve them, right? And actually, who is responsible, right? Because there also might be cases where bugs are found and not fixed. So maybe Kara, you could start, and Azra, you could add to it. So what's being done to fix them when you find bugs, right? And then who's responsible for that, especially in an open source setting?
This is a big question, actually. There's a lot, I know a lot of what's being talked about that's planning for the future, like how we would like to see where the situation in a utopia world where, we could get bugs just fixed across that low level of the iceberg with just sort of mass patches that are extremely easy for developers, so that just one button and have support on hand for the developers to help them get those things fixed. We're not there yet. Azra, do you want to address how things are working right now?
Yeah, so I have a little bit of experience being on one of those project teams that was responsible for triaging and fixing bugs. And the answer is, unfortunately, that it's project dependent. And it's up to the community members to just end up stepping up. So sometimes companies who are like involved in their open source dependencies will go and put engineers on those teams to go and help those security fixes to actually pull through. But in the end, it's a community maintained process, and people, sometimes develop processes and precedences for when they're going to fix bugs, but it doesn't always happen because this is an open source problem.
Yeah, and I would think also relating to that, not only just open source, many companies have bug bounty programs, right, where people find bugs and submit them, and then the companies become aware. So Google, often the acronym is VRP. So we have one, many companies have it. I think HackerOne is like one of the main VRPs that are out there, where actually if you find bugs, you can get paid for submitting them. We also hear in many companies, I know both Google and Microsoft have big research teams that will actually research things across the internet and then let companies know ahead of time, hey, we found this, right? Because there are sometimes you want to let companies know before you say post it on Twitter, right? So there are also some, I think, embargo rules, which I don't know if those are self-made up or we make them up, but there are rules or disclosure rulings that are around trying to give people time to fix their bugs before you blast it to the world. So those are things to kind of be aware in this space.
I just want to throw out the SOS rewards program. I think that's one of the links on that page, which whereas VRPs reward you for finding bugs, SOS rewards you for fixing or making proactive changes to harden and protect projects.
I totally forgot about that. So yeah, that's a great call. Yeah, so the sos.dev, right?
Yes.
Yeah, it's on the link. If you all look, I think the presenter view has it. So there's an attachment, like the logo on your email, that has the link to the page that we're referencing. So that project is kind of taking not just finding the bugs, but also finding the solutions and contributing back and actually be able to get some compensation for that. A Google specific. So how does Google handle the security of an open source tool if it's compromised or vulnerable? What does the incident response look like?
I can maybe take some of that. So it's a really difficult problem. So one thing that Google does is that a majority of their code is hosted and mirrored internally as well. And so a lot of enterprises will do this. And that'll help for them to ensure that they can patch a vulnerability quicker than it might be for the entire open source community to do so. But when it's a project that they're directly consuming from and they don't have that internal mirror, generally they'll try to see if they can be on sort of private disclosure lists, which is part of this embargo process and best practice software practice, where you can get people who are really relying on that software to get patches early. So a lot of the time, Google does recognize that this is a risk, and they'll do things like limit the number of open source packages they're relying on and try to get engineers to be on top of creating those fixes ASAP.
So trying our best, like everyone else out there, and working together. A couple more deep dives actually on some. I love seeing some of the questions here. So to either of you, are you familiar with the SBOM? Service bill order. You guys have to tell me. I forget right now.
Software bill of materials.
Of materials. Okay, totally wrong, Sarah. Are you familiar with the SBOM? And if so, what are your thoughts on its value and limitations?
It's
Sarah.
this is a complicated question. So software bill of materials, for those of you who aren't aware, is sort of like people keep calling it an ingredient list for software. So some of the big problems that we've been having are that we just didn't know what's in your software. How do you find out? So one of the solutions that's been floated for this is this software bill of materials. It was mentioned in conjunction with last year's executive order on cybersecurity. There was a push for SBOM production after the executive order. So people are involved in generating SBOMs right now. They're also working on tools that help you, once you have all of these SBOMs, if you're getting all of these ingredient lists for all your different packages and dependencies, how are you going to query them and understand what's in them? We're working on that. But there is one sort of addendum that I think we need to say in conjunction with SBOM. I'm going to let Ezra take over on this and how salsa provenance really plays in, because she's deeply involved in that.
Yeah, I guess maybe what Kara's also alluding to is that SBOMs don't necessarily describe your entire risk factor, because there's a lot that goes into a build besides just the materials. There's also the process. And so SBOMs are kind of like a ingredient list, but there's also that recipe portion that sometimes people need to know in order to trust the actual material that comes out. So that's where salsa comes in. If you're more interested in that, check out salsa.dev. There's also blog posts about comparisons between SBOM and salsa and limitations there. So one curious thing, if for the person who was asking this question, one thing that is interesting if you compare that to like food and ingredient lists is, do you always trust Kellogg for describing their cereal ingredients? And same with, do you always trust open source package A for providing the correct set of materials? So that's just like a thought question. And so, maybe in the coming months or years, people will start coming up with similar sorts of regulations and processes around auditing those SBOMs, but that's certainly a limitation that people are thinking of right now.
Yeah, and Azra mentioned salsa a couple of times. That's slsa.dev. Supply levels for software artifacts, I guess, pronounced like the dip.
Software levels for software, supply chain levels for software
artifacts. Yeah, that one.
Hence the acronyms. Acronyms. I'm also scared to see what the ingredient list in an SBOM is. If I think about what is in my ingredient list, sometimes I'm a cereal, those long scientific names for sugar. Okay, jumping to another question, this time on scorecard. So how are you able to run scorecard on 1 million packages every week? What about the GitHub API limit? Maybe just at the start of that, just a quick overview of what GitHub is and what sits in it.
Okay. I was ready to answer the first question.
Do that. Just the intro to GitHub.
So GitHub, oh gosh, Ozra can probably explain it better than I can. But this platform for hosting all sorts of open source projects, it's sort of like Open Source Central in a lot of ways. There are other options, GitLab and some others, and so there is this API limit. I think we have. Correct me if I'm wrong on this, Ezra, but I know that we're in contact with GitHub on this topic. And I think also we just have a bunch of tokens that we've been using that each person on the team has donated their tokens. So if there's anything else other than that.
I think in the community spirit of open source, we also community contribute tokens, which allow us to get rid of that rate limiting problem. But another thing that we do is scorecard action. So this is a sub-project of scorecard that allows the user to run scorecard in their own repository, which means that we don't have to run it ourselves. And then we do some tricks to make sure that they didn't tamper with the result or anything. So that's also a cool project. And if you Google scorecard action, you'll find some references about that.
Yeah, and on that point, so if you do use the scorecard action, which you should because it's great, I do believe that the default is that it won't share your score with us. But if you can go in and change that, it's in the documentation, flip that switch so that then it will share your score. That helps us with that API limitation. The more people who share their score, the fewer scans we have to run.
Wonderful, thanks. Next question, I think, is probably one that's top of mind for many developers. So what are your recommendations for securely developing, for example, web apps that typically incorporate a lot of OS packages? Are there rules of thumb for limiting dependencies and potentially insecure packages, such as those that get lower OpenSSF scores? And what should we do about packages that have vulnerabilities but no fixes currently available? That's summarizing the whole thing going on. So what are folks trying and best practices to do right now?
I'll briefly answer that with, I think that the best answer is limit your dependencies like you alluded to. So the less dependencies you have, the less you have to worry about, and the less attack surface you have, which is just going to make your headache a lot less. That being said, you're right. There are places where there are vulnerabilities and there's no fixes available. And sometimes people do a process called patching. So they'll pull in a dependency and patch it. But again, like I said, that's not the best solution. The best solution is simply get rid of it if you can. So there's a bunch of docs on secure coding practices by the OpenSSF as well that describe some of these. And yeah, I think, Kara, do you have anything to add, or did that kind of cover it?
I think that covers it. The only other thing that comes to mind, sort of tangential, is like, I think I mentioned in the talk, just having conversations within your org. If you can kind of just discuss and kind of set up, even if it's not an official policy, just sort of like, how do we feel about using projects that aren't using branch protection? Or are we going to decide a hard no on projects that something, some security trait that can help you define your risk tolerance?
Yeah, I think this is probably top of mind for every developer out there, right? The kind of risk tolerance and picking and choosing, and then keeping up with the new thing that happens there. Another question, is it challenging to keep up with new features and trying to secure them at the same time? I can imagine how many contributions must be submitted on a daily, weekly basis.
The answer is yes. Yeah, I think I've learned, especially as being involved in both feature teams and security teams, is that often you don't get a whole lot of reward for being on the security or maintenance aspect of projects. And sometimes people are more incentivized to do the feature role, but it's super important and critical that you don't, end up vulnerable or break people, because that's a lot more impactful and unfortunate to happen if you're breaking something or vulnerable. So yeah, I think that there is a balance that people need to have between feature building and security. And obviously we're a little bit biased being on a security team and probably think that security is a lot more important than building a new feature. I personally think better testing, automating security practices, those are all things that can help you make more features while still maintaining that security bar.
And to do a shout out also, there's not a specific episode on open source, but I think it is tied in a couple of places. I put in the announcement, Google actually, as part of Cybersecurity Awareness Month, just released a 6-part mini documentary that's on YouTube. If you just Google Hacking Google, or follow the long, ugly link I put there in the announcement, we have episodes on actually Google's history and approach to cybersecurity and how we've really built up and built in a culture of security first mindset here at Google. I think all of you on this call will find it super interesting. And it covers a number of our different teams and how, when we're thinking about features and tools, security really comes first to mind for Google. And it's also just really fun and well done. So I think it'll interest all of you here. A couple of questions I'm going to kind of group together, and I'm going to ask for Kara. Some of the questions are, it's, a lot of working in open source is very heavy on the coding side. You, especially as a career changer and focused on the technical writing side, one, how did you kind of ramp up, and how did you, if someone is trying to, get involved, say in a working group, but isn't necessarily a software engineer?
Yeah, I'm glad I see these questions. A couple are saying, do you need to read and code? Is it code heavy? The answer is not necessarily. It's great that you can contribute to open source projects through documentation. In fact, we really need more people contributing to open source projects through documentation, because the software engineers can put together these brilliant tools that are fantastic, but people you need to know how to use them, and you need to answer the questions that people have and explain to them why they're using them. So there's roles like technical writer. In my case, I touch code very infrequently. It's all really just marked down for me. And I used free resources. I didn't go to any boot camp or anything like that when I decided to switch careers. I just spent a lot of my free time on Code Academy and reading books and practicing and testing myself. And now I, as I said, touch code rarely. On the software engineer side, I think there are actually roles that have sort of less in the guts of the code roles, I guess is what I'm trying to say. There are some of our colleagues who work on helping open source projects adopt the tools that we're building. And so they're not actually building any tools and coding in that sense. They're reaching out to the projects directly and saying like, hey, we'd like to help you install scorecards. We'll give you a hand with this. And so the I'd say amount of coding that they're doing is much less compared to the, community outreach and answering questions and explaining to people, why this might be beneficial for them. So I would say that that's one of those like more community outreach, less coding sort of roles.
Yeah, just to very quickly reiterate before we run out of time, I think one of the things that Kara probably realizes is that when you don't communicate effectively to users how to use something or what its guarantees are, that leads to people using something insecurely. So when you have incorrect understandings about stuff, that can end up turning out to people using something the wrong way and then opening up a vulnerability. So I think it's really important that there are people out there who are communicating and documenting and outreach to people who are using software in order for this process to actually be effective.
Yeah, and maybe I'm biased since I'm a program manager, but project management, many folks within this group also need someone to help them along the way. Nothing against software engineers, but they're not always known for tracking down everything that they're doing. So helping people aligned, figuring out what are the priorities. So if you have 6 bugs, which ones really are the P0 or the P3s? Helping people figure out goals. Here at Google, we use a process called OKRs, which if you Google it, you can find, but many companies use it. So what are your objectives and key results? So how is a team who's working on a new feature or trying to tackle this huge tech debt, how are they going to do that? And how do they work together to do that? How is that communicated out within the working groups within OpenSSF? I'm sure too, you have someone who's taking meeting minutes, sharing, helping build consensus, right? A lot of open source is much more consensus building than other places. So how are you all working together? There's roles within that too. We are almost at time. I do see questions on opportunities at Google. We have a career site that's really the best place to find what's open now. So careers.google.com. We're also probably, I can't tell, I don't know the dates, but also internships for Google open early. They're probably opening soon. They might be open even now. So if you are someone who's interested in an internship, please look on our site, careers, and there's probably a students link. We do them much earlier than many other companies. So you apply in the fall for the following summer. And I'm sure the Ghost team will have some availability around that. So keep an eye on those things. Connecting with us on social media or LinkedIn. Personally, you can look me up. I'm going to speak for the others that you probably can look them up and add them to on LinkedIn. Also, hopefully, many of us will be at the WiCyS conference next March, so you can find us. Google will be there. So those are best ways to connect with us outside of this webinar. And we have 2 minutes, and there's one documentation question that we will take as the final, and then we'll do a final goodbye.
I'm not sure it's a documentation question, actually.
Okay. Well, okay. Then I didn't read the whole thing yet. While documentation of how to use software is needed, attackers will intentionally misuse software, so the entire coding process needs to be more secure. Thoughts?
Yeah, I think that's definitely true. And I think that documentation of secure coding practices also ends up being important. So yeah, it's important for people to use software correctly, and it's also important for that software to be secure. And so again, this is such a holistic effort. There's people on our kernel side making software as a whole more secure. So there's attacks on all fronts.
And I'll just throw in a plug. The OpenSSF recently, just in the past month or so, I think released 2 sort of 1-page, 2-pager documents. That one is an overview of secure software development. It's 1 page, but it's super dense. It will take you a while to work through everything. But I think if you just search OpenSSF 1-page guide, secure software development, you'll find it. And then the other was, I believe, a 2-page guide to assessing software. I think that kind of also helps in that question that we had earlier about how you decide, how you're going to handle your dependencies. That will cover it as well.
Yeah. And I would say to everyone, this is, cybersecurity is one of the fastest growing, most exciting fields there are. So if you're showing up here and interested, you're in a good space. There's lots of different places going on, lots of needs, lots of jobs, and lots of volunteer opportunities. So definitely stay connected and check out some of the resources shared. I want to say a huge thank you. Also, we didn't fully see your shirt, so you both need to lean back a little or up a little. There we go. There's the Ghost t-shirt, super cute. Thank you, Kara. Thank you, Azra, for sharing your knowledge with everyone here. Thank you, Morgan, who's in the Observer queue somewhere, for helping us organize this, and the whole WiCyS community for coming and learning with us. And hope to see many of you across the web.
Thank you so much.
Thank you.
Thanks all.